Okay, this video is about how to do the light energy calculations, and this was the homework that I assigned on Google Classroom. And what I'm going to do is I'm going to do the odds. So the first thing is this says calculate the wavelength in nanometers of a photon with a frequency of 2.8 e to the ninth hertz. Well, the first thing to be aware of that a hertz. So a hertz is Hz, that's the abbreviation. Okay, that Hz is the same thing as the number of cycles per second, which a lot of times I just show that as seconds to the -1 power. This is the same unit as a hertz. So seconds to the -1. So when you get this, calculate the wavelength in nanometers of a photon. All right, look at the top of the page on the homework, and I have the formulas and some things that you need to know up there. So basically what you'll see is you'll see that the speed of light, and these things are spelled out on the green sheet also, but the speed of light equals the wavelength times the frequency. All right, and so basically if we're trying to get the wavelength, we can do a little math here, and we can take the wavelength, which is on the top, and we can move it to the other side over the bottom. Oh, hold on a second. I don't want to do that because I'm looking for the wavelength. So we need to move the frequency. So let's move the frequency is on the top. Let's move it to the other side. It will go to the bottom. And so the wavelength will be equal to the speed of light over the frequency. All right. So then, frequency, not wavelength. Okay, there we go. All right, so we can plug in some numbers here. So wavelength equals the speed of light, which is 3.0 e to the 8th meters per second. If you look at the 8 on the green sheet, I think they go to like 2.998, I think, meters per second. All right. But anyway, that's what it equals. We're going to divide that by the frequency, which is 2.8 e to the -9, and that would be seconds to the -1. All right, and so then what happens is your seconds will cancel when you divide those, and so if you do that, you get that the wavelength is equal to 1.1 e to the 17th meters, but they want it in nanometers. So at the top of the worksheet, you can see that there's a conversion factor that 1 meter equals 1 e to the ninth, the nanometers to the ninth power, nanometers. And so if you do that math, you end up getting 1.1 e to the 26th nanometers. Oops, nanometers. Okay, that's number 1 on the worksheet. I'm going to skip to problem number 3. So 3 says calculate the frequency, and we have wavelength. So we're going to use the same formula. Speed of light equals the wavelength times the frequency. And so this time we're calculating the frequency. So we're going to move the wavelength to the other side. It's on the top, it goes to the bottom. And so frequency is going to be equal to the speed of the light over the wavelength. So the first thing is that we'll write is the frequency equals the speed of light. So 3.0 times 10 to the 8th meters per second. Okay, now we want to divide that by the wavelength, but if you notice the wavelength is in nanometers, that has to be changed to meters so it matches up with the speed of light unit, which has meters in it. So we'll just say in 1 meter, there's 1 e to the ninth nanometers. Again, that conversion is on the top of the worksheet. And anyway, let's see here. So 600, so that's going to be 6 e to the 7th. So 6e, and that's going to be to the -7th meters. So that's going to go down here. 6 e to the negative 7 meters. And so if you divide those two, you end up getting 5e to the, let's see here, 14th. So the frequency equals 5e to the 14th. And the meters, if you notice, will cancel. And it's basically going to give you seconds to the negative 1, which is the frequency unit. All right. So let's do another problem here. Let's do number 5. Okay, so number 5, calculate the energy of a photon. Well, there's a formula that the energy of a photon, E, equals Planck's constant times frequency. So energy equals Planck's constant, and that's 6.62 e to the negative 34 joules times seconds. So joules times seconds. That's Planck's constant. That's given at the top of the worksheet. I think on the green sheet that I gave you, it's like 6.626, I think, if I'm just kind of guessing on that. Seems like I can never remember that last number. Okay, but anyway, we're going to take that times the frequency, which is 1.9 e to the negative 13th seconds to the negative 1 power. That's the same thing as a hertz. Notice that seconds will cancel, leaving you with units of joules. So if you multiply those out, you end up getting, I think, if I did it right, 1.3 e to the negative 46 joules. Okay, that's problems 1, 3, and 5. You should try problems 2, 4, and 6. I'll be making a second video that goes with this in a few minutes here.